Hi, this is problem number 3 on moment of inertia. It is asked to find least radius of gyration. Okay, least radius of gyration for the figure. The procedure is same as that of previous problem. Okay, so we have to find radius of gyration about x-axis and radius of gyration about y-axis. Whichever is the least value, that will be the least radius of gyration. Okay, means initially we have to find ixx and iyy, moment of inertia about the x-axis and the moment of inertia about the y-axis. Okay, so to find moment of inertia about x-axis and y-axis, we will use we have to use these set of formulae. Okay, just check the symmetry of the figure. The figure is not symmetric about x-axis, right? It is not symmetric about x-axis, and figure is also not symmetric about y-axis. So we have to find ixx and iyy using these set of formulae only. And reference axis you need to draw. So this is reference 1 axis, reference 1 axis, and reference 2 axis. Okay, reference 2 axis. And an important thing is here we can see that the triangle, rectangle and semicircle, there are three components. Out of these three components, the semicircle is an unshaded portion. Okay, semicircle is an unshaded portion. Therefore, while finding the total area, you need to deduct area of the semicircle. Means you need to take negative sign for the semicircle. Also, while finding igx and igy values, you need to take negative sign for the semicircle. Remember, this is very important. So if you forget to take a negative sign, the problem will go wrong, means the solution of the problem will go wrong. Okay, now there are three components here. First one is rectangle, second one is triangle is there, semicircle is there. Just I will change the numbering of the components here for convenience. I will take say semicircle as component number 2 and triangle as component number 3. Triangle as component number 3. Okay, so before going to solve the problem, let me write the formulae. Okay, centroidal formulae. For triangle it is h by 3, and from here it is 2b by 3. Okay, so how it is 2b by 3, I have explained in detail in centroid chapter. You can go through the problems on centroid of plane figures. You can understand clearly if you get any doubts here in formula. And for semicircle, this is component number 3 now. Let me call as G3. This is G2. For semicircle, this distance from diameter it is 4r by 3 pi. 4r by 3 pi. From its edge it is equal to radius. Distance of centroid, distance of G2 is equal to radius. Okay. For rectangle it is b by 2 and d by 2. Okay, G1. Okay, so we have to find ixx and iyy. To find both ixx and iyy, so we need to add all these parameters. Okay, area x, y, ax, ay, ax square, ay square, igx and igy. Okay, so all the parameters are there in this table. Okay, we will go on finding the values for each and every components. What is the first component? First component is rectangle. Rectangle 1. First component is rectangle number 1. Area is B into D. What is width of rectangle? Total width of the rectangle is 50 plus 50, 100 mm. 100 mm. And depth of rectangle is, it is 25 plus 30. 25 plus 30, 55 mm. 55 mm is the depth of rectangle. Okay. So 100 into 55. 100 into 55. It is 5500 mm square. So units are millimeter square, millimeter, millimeter, millimeter cube, millimeter cube, millimeter raised to 4, millimeter raised to 4, millimeter raised to 4, and millimeter raised to 4. Then coming to the x value for rectangle, it is b by 2 from reference 1 axis. B by 2, 100 by 2, 50 mm. Coming to the y value for rectangle, it is d by 2, distance of g1 from reference 1 axis. D by 2, 55 divided by 2, which is equal to 27.5. 27.5. Okay. Then for rectangle, the second component is what? Semicircle. 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 Component number 2. See, area is minus pi r square by 2. Why minus? Because it is unshaded portion. We have to find the moment of inertia or the radius of gyration for only the shaded portion. That is why you need to deduct the area of the semicircle. That is why minus pi r square by 2. Therefore minus pi into, what is radius? Diameter is given as 50 mm, radius will be 25. Okay, the radius will be 25. Pi into 25 square by 2. By 2. The answer is minus 981.74. Minus 981.74. Okay. Then coming to the x value for semicircle, distance of G2 from reference 1 axis, it is 50 plus radius. 50 plus radius. 50 plus radius is 25, 75 mm. Coming to the y value, distance of G2 from reference 1 axis, it is 4r by 3 pi. 4r by 3 pi. 4 into 25 divided by 3 pi. Answer is 10.61. 10.61. Now we will perform the calculation for the third component, triangle. Triangle, which is component number 3. Half into base into height is the formula. Half BH, which is equal to half into base width of triangle. It is equal to the width of the rectangle, correct? 100 mm. 100 mm. Height is 30. 100 into 30. 100 into 30. Answer is 1500. 1500. Coming to the x value for triangle, it is 2b by 3 from distance of G3 from reference 2 axis, 2 axis, 2b by 3. 2b by 3, which is equal to 2 into 100 by 3. Answer is 66.67. Okay. Then coming to the y value for triangle means distance of G3 from reference 1 axis, it is depth 55 plus h by 3. Okay, 55. So this is the y value for rectangle 3, correct? Distance of G3 from reference 1 axis. So it is from here to here, it is 55 plus h by 3. Okay, so here you write 55 plus h by 3. 55 plus height of triangle is how much? 30 by 3. Answer is 65 millimeter. 65 millimeter. Now coming to the ax, ay, ax square and ay square. Here it is 2,75,000. 2,75,000. Ay is 151,250. Ax square is 13.75 into 10 power 6. Ay square is 4.15 into 10 power 6. Please cross check the answers. Then IGX for rectangle formula is BDQ by 12. BDQ by 12. So it is 100 into 55 cube by 12. The answer is IGX 1.38 into 10 power 6. IGY is DB cube by 12. 55 into 100 cube by 12. Answer is 4.583 into 10 power 6. 4.583 into 10 power 6. Okay. Then for semicircle, AX value is minus 7360.5. Minus 7360.5. AY is minus 10,146. Okay. And AX square is minus 5.52 into 10 power 6. Then AY square is minus 110,516.5. Okay. Then IGX formula for semicircle. Okay, let us go to the formula. See what is the alignment of the semicircle. It is like this. Okay, for this alignment, IXX is equal to 0.11 r to the power of 4 and IYY is equal to pi r raised to 4 by 8. Okay, and very important, you need to take negative sign because semicircle is an unshaded portion. Okay, semicircle is a unshaded portion, that is why you need to take negative sign. So IGX formula, what is IGX formula? It is 0.11 r to the power of 4. IGY formula pi r raised to 4 by 8. So here I will write minus 0.11 r to the power of 4 minus 0.11, radius is 25 to the power of 4. The answer is 42,068.75. Negative sign. Okay, and minus pi r raised to 4 by 8. Minus pi into radius is 25 to the power of 4 by 8. With respect to the semicircle, you should be careful. Depending upon the alignment, the formula will change. For this horizontal alignment, these two are the formula. Okay, and for vertical alignment, both the formula will be interchanged. Okay, both the formula will be interchanged. Okay, so here answer is minus 153398. Okay, and one more thing, you may get some difference in last 2 to 3 digits. Don't worry. Okay, don't worry, just carry on. Finally you will get the same answer for radius of gyration kx and ky. Okay, or you will get the same answer for ixx and iyy, moment of inertia values. Okay, there may be difference in last 1 or 2 digits. Okay, because sometimes what happens is pi value, okay, in the calculator, uh, sometimes we will input as pi only, sometimes we will input the pi value as 3.142. There uh, some deviation will take place. No need to worry, you just carry on with your calculations. If there is slight difference in last 2 to 3 digits, okay. Then for triangle, ax is 100,005. Okay, ay is 97,500. Ax square is 6.66 into 10 power 6. Ay square is 6.33 into 10 power 6. Okay, for triangle we know the formula, ixx and iyy. It is bh cube by 36 and hb cube by 36. Bh cube by 36, b is 100 into 30 cube by 36. Okay, answer is 75,000. Okay, here the formula is hb cube by 36, which is equal to 30 into 100 cube by 36. Answer is 83333.3. Okay, in terms of exponential form also you can put the answer. Okay, in terms of 10 to the power form you can put the answer. That will be a easy way to write the answers. Okay, now we will calculate the sum of all the parameters. Total area is equal to, cross check your answers, it is 6018.26. Okay, sigma ax is equal to 30 means 301374.5. okay, sigma ay is equal to 238604. Sigma ax square is equal to 14.89 into 10 power 6. Sigma ay square is equal to 10.36 into 10 power 6. Then sigma igx is equal to 1.344 into 10 power 6. Sigma igy is equal to 5.26 into 10 power 6. Okay, so to this tabular calculation is over. Next step is we have to use these formulae. Okay, we have to use these formulae. First formula is I11 is equal to sigma igx plus sigma ay square. I11 is equal to I11 is equal to sigma igx plus sigma ay square. Sigma igx is 1.344 into 10 power 6 plus sigma ay square is 10.36 into 10 power 6. The answer is 11.704 into 10 power 6. 10 power 6 millimeter raised to 4. Then second formula, I11 is equal to Ixx plus A into y bar square. I11 is equal to Ixx plus A into y bar square. Rewrite this formula as Ixx is equal to I11 minus A into y bar square. We need the value of y bar now. Y bar is equal to sigma Ay by sigma A. Sigma Ay is how much? 238,604 divided by total area 6018.26. By this you will get the y bar as 39.64 millimeter. Then you substitute all the values. I11 is equal to 11.704 into 10 power 6 minus A into y bar square. Total area 6018.26 into y bar 39.64 square. By this we will get Ixx, that is 2.247 into 10 power 6. 247 into 10 power 6 millimeter raised to 4. So this is the moment of inertia about x axis. Similarly, to find moment of inertia about y axis, we have two more formulae. I22 is equal to sigma igy plus sigma ax square. I22 is equal to sigma igy plus sigma ax square. Sigma igy is 5.26 into 10 power 6. Sigma ax square is 14.89 into 10 power 6. Okay. So moment of inertia about axis 2 is equal to 20.15 into 10 power 6. mm to the power of 4. Then the last formula is I22 is equal to Iyy plus Ex bar square. I22 is equal to Iyy plus A into x bar square. Rewrite this formula as Iyy is equal to I22 minus A into x bar square. I22 is here we need x bar value, no? We will find it first. X bar is equal to sigma ax by sigma a. Sigma ax is 301374.5 divided by total area 6018.26. The x bar answer is 50.07 millimeter. Now we can substitute all the values in this formula. Therefore, moment of inertia about y axis is equal to I22 20.15 into 10 power 6 minus total area 6018.26 into 50.07 square. By this we will get moment of inertia about y axis, that is 5.06 into 10 power 6. 10 power 6 millimeter raised to 4. Okay. Now we will find radius of gyration about x axis and the y axis. Radius of gyration about x axis is equal to root of Ixx by A Ixx, how much we got? 2.247 into 10 power 6. 10 power 6 divided by 6018.26. Kx value is 19.32 millimeter. 19.32 millimeter. And ky, radius of gyration about y axis, is equal to Iyy divided by a root of Iyy by a. Iyy is 5.06 into 10 power 6 divided by 6018.26. By this you will get the answer ky as 28.99 millimeter, almost 29 millimeter. Okay, 29 millimeter. Okay, now in this which is the least one? 19.32 millimeter is the least one. Therefore finally you write least radius of gyration, least radius of gyration is equal to kx is equal to 19.32 millimeter. Okay, so to this we got the least radius of gyration which is asked in the question. Okay, so we have done with this particular problem. If you have got any doubts in any of the steps in this problem, you can post your doubt in the comment box. Okay, thank you.